So I think most of you can answer this question if I ask you this question. What's 3 to the 4th over 3 squared? I think I asked you this question last time, Angelina and Gail, you were both here. Would you be able to answer this for me?
Hold on, I'm still taking notes.
Wait. 81.
81.
3 to the 4th power is 81.
Okay, why don't we do this? What's the first step you should do?
3 times 3 times 3 times
Yeah, okay, I love it, love it, love it. You're awesome, you're amazing, you're perfect. So 3 times 3 times 3. Yes, on top you have 4 3s, right? Because that's how you represent 3 to a 4th. And on the bottom you have 2 3s, right?
Yeah.
So then if you look at the top...
81, the bottom's 9.
Say that one more time.
The top result is 81. The bottom result is 9.
Yes, you're right. But here's a simpler way of doing it. If you don't want to do all the math on top and on the bottom, you can just cancel stuff out. You can take 1 from the top and cancel it with 1 from the bottom. 1 from the top, cancel it with 1 from the bottom. And all you're left with is 3 times 3. And what's 3 times 3? It's 9. 9. I think that means no in German, right? 9. Anyways.
Yeah.
Yeah, I'm right. Okay, great. You guys saw that you can do it this way, right? And this way makes sense. But what we want to know is, how do we handle bigger numbers? So that's why we have the quotient property for powers that says if you have two numbers with the same base, and when I say base, I'm talking about these 3's, then you can just subtract the exponents. So another way of doing this problem, this same problem, is like this. You have the same base, which is 3, and all you need to do now is subtract the exponents. So you take 4 minus 2. Angelina, tell me, what is 4 minus 2?
With 2.
2, so it's just 3 squared. And what's 3 squared? It's just 3 times 3, which is 9. It's the same thing. See? We did it 2 different ways. So can you guys answer me this question then? So this would be like our first like official example. 8 to the 5th over 8 to the 3rd. What is that? I want you to think about that for a second while I write it. And note that you can do it really quickly if you just use
3, 2, 7, 6, 8.
So what's 5 minus 3? It's 2. So what's 8 squared? 64. Ooh, what about something? Ooh, okay. Since you guys like to do it by the hard way, do this one. 4 to the 3rd times 4 to the 9th over 4 to the 11th. How do you do that?
Okay, hold up.
We just went from 0 to 1,000 real quick.
That's 1,000?
I'm just kidding. 0 to like 10. So if you guys watched or learned anything from the last video, what do you do with the top part when you're multiplying stuff that has the same base? You do something called the product property, where if you're multiplying two things with exponents and they have the same number in front, the same big number, all you do is add the exponents. So we're going to do 4 to the 3 plus 9. And then take the 11. Okay, 4 to the 11th. Now what's 3 plus 9? It's 12. So we got 4 to the 12th over 4 to the 11th. And then I hear rapid typing. But now what's the next step? After you have this, what do you do? I'm going to call on Gael. What do you do next?
Okay, so we're on equals 4, on the equals 4, 12, 4 to the power of 12, and 4 to the power of 11.
Yes, I love that you said it correctly. Yes.
Okay, so basically, since it's 12 power, and 4 down there is 11, there's basically just going to be 1.
Yes! Oh my god, yes, you're right. Yes. So, how'd you get 1? You're right.
Because 12 minus 11 is 1.
Yes, you saw that they have the same base, so you can subtract the exponents. Yes, you're right. So it's 4 to the 1, which is just 4, right? It's just 4 to the 1 is 4.
I'm so smart, bruh.
Bruh, yes you are. Okay. So I have one more example, a challenge problem, and then I'm done. So very quick, just little lesson. So second to last example is this one. What if you have two fractions and variables? We have two fractions being multiplied together that have exponents. I'm going to call Angelina. Angelina, if I told you to multiply these two fractions that I'm writing over here in red, top right on the side, how would you multiply those two things?
I don't know. I'd run away.
Okay, let's pretend that you can't run away, that you are trapped. You have to answer this to be able to get out. How do you answer it?
Bruh. Oh my god.
I know, I love scenarios.
3/6. You multiply straight across.
You love it. Yes, you multiply
What was
straight.
that? What was that band? I just heard like.
I was banging my chair because she's right. You multiply straight across, so it's just 1 times 3, which is 3, and then 2 times 2, which is 4. It's 3/4. That's it. So I asked you that question because all you do is multiply straight across, right? So for example number 3, all we're gonna do is just multiply straight across. So we're gonna multiply x to the 10th times x to the 5th over x to the 4th times x to the 3rd. All you're doing is multiplying straight across. And from the previous example, what did we do when we were multiplying stuff that had the same base? What did we do with the exponents, Gael?
Okay, so we're on x10 times x5 and.
Yep, just look at that. Ignore the bottom. Just look at that. How do you do the top one?
You subtract or you combine.
I like the second word you said. You combine. They have the same base. It's x to the 10th times x to the 5th. What do you do with the x?
Them equals 15.
Yes. Oh my God. 15. Yes. You're so smart. Now you got x to the 15th. Angelina, I want you to do the bottom one. What is the bottom one then? Gael did the top one, which he got x to the 15th. He went, I'll draw an arrow from it. He went from here to here. Now I'm asking you to go from here to here. What's the bottom? What's x to the 4th times x to the 3rd?
X7?
Yep. Okay, yes. Oh my God, fabulous. Okay, yes, so we have now x to the 15th over x to the 7th. So what do I do now that I have the same base? I have an exponent on top and the bottom. I can subtract them. So I'm going to take 15 minus 7. And what is 15 minus 7? It is going to be 8. And that's it.
It equals x1.
Did you just say the answer?
Yeah, I just said x1.
Oh my God, you are so yes.
All you gotta do is subtract the bottom number with the top.
Yes, exactly. So you get x to the power of 100 minus 99, which what is that? X to the 1, which is just x. We just get x. So we're done.
Was that the challenge?
No, this is the challenge problem. This is the challenge problem, which is 8 to the 33 over 2 to the 98. The answer's smaller than 10. So
The answer's what?
yep. Here's the process of doing this one. You need to get the same base on the top and bottom. You need to get a 2 is what you need to do. So is there any way of changing 8 into 2? Have you guys ever seen a factor tree? Do you guys know what that is?
Yeah.
Okay.
4,
So
4.
No.
so if I try to factor out 8, what do I get? 4 and 2,
4.
right? 4 times 2, right?
Uh-huh.
And then if I try to factor out 2, okay, I can't do that. What if I try to factor out 4?
Yeah, you can do that. It equals 2.
2 times 2, right?
Yeah.
Okay, perfect. Okay, love it, fabulous. So how many 2's do I have?
You have
3.
2.
You have 3 2's, right?
I'm blind, I'm sorry.
Okay, it's okay. We forgive you this time. Now, we have 2 3's. So this is going to be 2 to the 3rd. 2 to the 3rd is the same thing as 8. So let's go back to this. You get 2 to the 3rd. 8 is the same thing as saying 2 to the 3rd. So I can rewrite this. I'll do it in this color. No, wait, that's too skinny. I'll do it in this color. So you can rewrite 8 as 2 to the 3rd. And then that 33, you're just going to keep it on there. All right? And then you get 2 to the 98. So now the next step is to take care of parentheses. So here's what you do with the parentheses. When you have this 2 to the 3rd to like another power, which is crazy, all you do is multiply the exponents. So you're going to multiply 3 times 33. So I'm going to ask Angelina, what is 3 times 33?
99.
Yeah, you're right. Okay, perfect. So you get 2 to the 99 over 2 to the 98. So, Gael, what's the answer?
298, to the power, 2 to the power of 1.
2 to the power of 1, because 99 minus 98 is 1. That's it. Oh my god. Let me check the chat. Oh, there's 7 messages. I haven't even seen it. Oh, Gael is pretending to laugh. Finally, I want food. I'm hungry too. I want breakfast. I have the
I haven't
biggest
eaten
head in
breakfast.
the
I've only
world.
had
I
hot chocolate.
mean, I can agree with that. This is the nicest teacher in the world. Don't spread lies, Gael. Right, he is not boring, but not rude. Don't start with me.